Hello, my dear students. Welcome back to your class. Yes, we already are done with paper 2, right? And I hope you all would have understood all the questions, all the concepts related to the core, I should say the extended paper 2 of IGCSE O level. Isn't it? We already have covered the October-November paper of IGCSE O level, and now we are going to do paper number 4, that is extended, that will be consisting of 130 marks, and it is going to be of 2 hours 30 minutes. Again, that is of IGCSE. So I hope you all are ready to solve all the questions related to the paper 4, and you are ready with your queries, and I hope I'll justify your queries and will make you pro in mathematics. Let us start. Look what we have. We have this Cambridge IGCSE Mathematics paper 4 extended, and if I just turn the page, look here, that this is going to be the front page, and on front page we are being given with all the instructions. This is the barcode, which is very important, and I told you that nothing should be written on the barcode. Here is the details of the paper. We always need to start by writing the candidate's name, then the center number and the candidate number. But even before writing this, you should first read the instructions, because you will be given ample of time to read the instructions. The reading time is separately given to you, isn't it? So once we are done reading the instructions, then only we'll start filling up the details. So if I look at it, this paper tells me that it's mathematics paper 4, the extended one, October-November 2023. 2 hours 30 minutes is the time allotted to us, and 580 is the code, paper code, and variant of that is the 42, right? Let us now look at the important instructions. As we know already that we start by writing the name, and we chose Peter Parker, isn't it? Our Spider-Man. Yes, so you will write your name over here, followed by the center number. Center number could be anything like A, B, C, 1, 2, it depends. Candidate number could be 0, 1, 2, 3, and these are the details. Mathematics paper 4 extended. 580 is the subject code, 42 is the variant, that is of October-November 2023. This is the time allotted to you, right? 2 hours 30 minutes is the writing time. And this is going to be, the answers must be given on the question paper itself, and you are allowed to use the geometrical instruments. Okay, we already have discussed, the basics of writing the paper. We are just getting the feel of it. The paper 4 is a bit different than paper 2. In paper 2, you get, only 70 marks questions, and there you get the basics, or I should say the conceptual questions, wherein in paper 4, you will find the real life applications, or the applications of the knowledge which you have already studied, isn't it? Now, if we look at the instructions over here, the first instruction is answer all the questions. Again, this paper also need to be attempted in full. None of the questions are supposed to be left behind. Next, use a black or dark blue pen, guys. Very important point. We need to use a black pen or a dark blue pen. I would rather suggest you that we should stick to a black pen. Then you may use an HB pencil for any diagrams or graphs. If there is requirement of drawing a diagram or a figure, you can use the HB pencil for that, especially for construction and translation. And also for graphs, you can use the HB pencil. Now write your name, center number, and candidate number. These are very important 3 details that needs to be filled by you, and that too very authentic detail, right? Your name should be properly mentioned, your center number given to you in the admit card should be mentioned, and the candidate number, that is going to be your roll number, must be written properly without any mistake on that paper, the first page of the paper. If I just show you, this is what here you will write it, isn't it? Moving ahead, write your answers to each questions in the space provided. That means in front of every question you will be given the space, and you can use that space to write the solution or the answers. Then do not use an erasable pen or correction fluid. Again, the same instruction. We should not use any correction fluid or any erasable pen. Do not write on any barcodes. Guys, very important part. These are the barcodes. You know, this is the barcode. And you're not supposed to write anything on this barcode. You're not supposed to write or scribble anything on this barcode, because these barcodes are scanned to, you know, get the information about the candidate, and if you write anything over it, it might get distorted and then your candidate's information will be missing. So do not try to write anything over it. So yeah, moving ahead. Here next is that you should use a calculator wherever appropriate. So we are allowed to use the calculator wherever its use is allowed. Okay. Next, you may use tracing paper as well. You can use tracing paper for, you know, translation purposes or any other sketching purposes. You must show all necessary working clearly. Guys, it's very important. Now, you know, many students, they tend to not show all the necessary working, and they simply write the answers by doing the calculations orally or just doing it in the calculator. No, that's not allowed. That you should not do it in that way. You should show the workings very clearly on the space provided. There is ample of space where you could, you know, write these steps. So writing steps is very important. If a question is of 2 marks, 3 marks, or even 4 marks, so there you need to show the relevant steps. If you're not going to write those steps, your marks will be deducted even if you get the correct answer. Just for writing an answer, you won't get the full marks. I'm telling you guys, if all the steps are correct and the answer is wrong, even then you will get the marks for the correct steps. But if the steps are not there and only the answer is there, then, you know, the one who is going to correct your paper will think whether you have done it by yourself or you just have used, you know, any random thought to get the answer. So better would be to always write the steps and then get to the conclusion or the answer or the solution of the question. I hope this part is clear. Now, give non-exact numerical answers correct to 3 significant figures. Guys, 3 significant figures. Again, I am telling you, we are being told to write the answers in 3SF or 3 significant figures, or in other case, we can use 1 dp, 1 decimal place for angles in degrees, unless any other level of accuracy is specified. Clear? That must be in the know. And pi, for pi we either use calculator or the value 3.142. It's already being given that pi will be substituted by the value 3.142. These are the important instructions, guys. And one more thing which I want to tell you here, this total mark, or I'll show it over here. This, you know, information is the total marks of this paper is 130. This paper consists of 130 marks, guys, and the number of marks for each question or part question is shown in the square brackets in front of it. So yes, we are now clear with all the instructions, just same as the instructions that were there in paper 2. Let us begin. Now guys, okay, the very first question, I see a graph over here. Isn't it? You know, this is the coordinate axis, x-axis the horizontal one and y-axis being the vertical one, and now we have the coordinates of the points, or I should say that we have the numbers, you know, being allotted on the line. So this question is about translation, rotation, enlargement, transformation, that everything that we, you know, have studied in the translation chapter, that will be tested over here. Okay, so what is our first question? The first question is translate triangle T, which I find over there. Let me enlarge it a little bit for you guys. Yep, so this is what it is. We have the triangle T over here. This is the triangle T. So we need to translate triangle T by the column vector -7 by 1. Label the image as K. Very interesting thing, guys. If I look at this, I am being given with the, you know, column vector -7 comma or -7 by 1. So this thing is very clear that the number or the digit which is written in the numerator in the column vector is representing the translation of that shape or of that figure in left or right direction. The upper number shows the translation is in either left or right direction. That means I want to tell you it is going to be shifted along the x-axis. That's the x coordinate, I should say. And when I look at the number which is in the denominator, that is 1, it represents the movement of the triangle either up or down. That means it is along the y-axis. So how could we know that whether I need to move this triangle left or right? I am being given with this -7. 7 tells me that this needs to be shifted 7 units. But in which direction? Left or right? You're correct. If it's a negative sign, it tells us that we need to go in the left direction. If it would have been +7, then we would have moved in the right direction. So now if I talk about this -7, this point, if I just this point, and this point, these are the 3 vertices of this given triangle T. So the vertex, this vertex should move 7 places to the left. It has to move 7 places to the left. So if I do so, let me count. This is its original place. 1 place to the left would be this. This is 2 places to the left, 3 places to the left, 4 places to the left, 5 places to the left, 6 places to the left, and then at the end, this is the 7th place to the left. Or I should say 7 units are being shifted to move this vertex from here to its leftmost point, isn't it? So will I have that vertex over here? No, not yet. We need to check again that is there any movement in up direction or down direction. For that, let us look at this. Yes, we have a number 1. It's a +1. That tells us that this vertex also needs to move above or up in 1 unit. Isn't it? So this point will move 1 unit above. So this is the new position of this vertex. Which vertex? This vertex. I have to translate. I need to move this vertex from here till here. That is the translation of this vertex in the left direction 7 units and up direction 1 unit. I hope you are being clear over here. I'll just erase all this. And if it is the case, this also will happen with this vertex. 1, 2, 3, 4, 5, 6, 7. 7 places to the left and 1 place up. So this is now the new position of that vertex. Right? And now we are left with only the topmost vertex. So if I have to move it 7 places, what would I do? 1, 2, 3, 4, 5, 6, 7 and 1 place above. So it is going to be at this position. So it is going to be at this position. That means these are the vertices of the translated triangle. Let me join it. How would you join it, guys? You need to use your ruler and your black pen or pencil and you will join these vertices like this. Again we'll use, this is the base of the triangle followed by this perpendicular and then we will have the hypotenuse. Isn't it? This is our required translated triangle. And how do we label it? We are labeling the image. This is the image. This is the object. And once it has been translated, this becomes the image and we will name it as K. Am I being clear, guys? I'm again explaining it to you. We just need to look at the column vector. Very simple thing. The number above tells us the translation of the object on either left side or right side. If the number above is negative, we will move left. If the number above is positive, we will move right. That many places or units as that number suggests. and the number which is down, it represents the movement of the object either in the upward direction or in the downward direction. If the number in the denominator is positive, we will move up, or if it's negative, we will move down. That many places at that number is suggesting, right? So this is the part 1 of this question. We have translated triangle T by the column vector -7/1, and we have labeled that image as K. I hope it's clear, right? Now let us move to the next part of the question. This is 2 marks question. So if we have done proper translation and also labeled it correctly, you will get full marks. Next part. Describe fully the single transformation that maps triangle K onto triangle T. Okay, I am using different graph pages for every part, although you need to solve it in a single graph page that is going to be there on a single printed page. You will draw everything over there only. But this question is not about drawing. It's about we need to describe fully the single transformation that maps triangle K onto triangle T. So if I look at it, or if I draw it over here one more time for our reference, we know that it was here. Right, this was the position. I'm drawing it for you one more time. And yes, it was like this. This is our triangle K, isn't it? So now if I have to fully I have to describe fully the single transformation that maps triangle K onto triangle T. That means I'm just asking, what should I do to just get back this triangle K to the position where the triangle T already is? So guys, we know that from T to K, what we did from T to K? Let me just write. From T to reach to K, we have done the transformation of -7,1 or -7/1. So to reverse this process, to transform or to map triangle T completely to triangle T, I will reverse the process. That means this vertex, if I talk about this vertex, guys, particularly, if I have to move it from here to here, look, what would I do? I would move to the right side. How many places? Let us count. 1 place, 2 place, 3 place, 4 place, 5 place, 6 place, 7 places. And I will move 1 place down to get it here. That is what is the single transformation. That we need to move 7 places on the right side. So there will be a positive number. And also I am moving 1 place down. So the negative number will be here. So it is my 7, or 7 by -1. So what we will write over here? We will write translation 7 units to right and 1 unit down. This is the fully description of single transformation that maps triangle K onto triangle T. So if you write it like this, or if in bracket, if you mention that the column vector, that will also do. So the column vector was +7 by -1. This is the single transformation that maps triangle K onto triangle T. I hope I am being clear over here and you have understood this part. This is only 1 mark question, so this much is enough. Moving ahead, guys. Next, yes, what do we have over here? Now we have to reflect triangle T in the line y equals to 4. Guys, first of all, we need to have a line y equals to 4. You would be doing it on that same page, but I am just writing it over here. So what will be the reflection? The reflection at y equals to 4. First of all, I need to have a line at y equal to 4. Where is y equal to 4? Actually, y equal to 4 is over here, isn't it? So if I have to draw a line, it will be parallel to x-axis. So it will go like this. Isn't it, guys? We will write its name as well. This is y equals to 4, right? This line is y equals to 4. Now I have to reflect this triangle T in line y equals to 4. That means I would imagine this to be a plane mirror. So what would be the image of T look like? Just upside down. So if I draw it, it would look like this. I'm just doing it for you. Have a look. This thing, then the reflection of the base would be like this, and then the reflection of the hypotenuse will be this. Right, guys? This is what is being asked. We have reflected triangle T in the line y is equals to 4. I hope you are clear with this part. Very easy. You just first need to draw a line y equals to 4 that will be, passing through coordinate of y from 4 and will be parallel to x-axis, and also to reflect it, it will just be the mirror image of triangle T. Okay. Now moving ahead, rotate triangle T through 90° clockwise about 0, 0. That means, guys, I have to rotate the triangle T now, not the image of triangle T. We are talking about only triangle T. So triangle T's rotation, also you need to be very clear that whether it's clockwise or anti-clockwise, what is the degree given to us. Here it is being given that it has to be 90° clockwise and it has to be about the origin. Okay, the center should be 0, 0. So let me tell you one very basic trick for this. We should know it already. Like if we have, to rotate any shape 90° clockwise along the origin, about the origin. So what do we need to do? Look what it becomes. I am writing it, rotation of 90° clockwise about origin, that is 0, 0. So what we need to do? We need to do this thing, that the coordinates, whatever may be the coordinates of the original shape, they will interchange their places. That means x becomes y and y becomes x, and also we have to put a negative sign on the y coordinate, the new y coordinate. I am telling it again, guys. Whenever the rotation of an object has to be done 90° clockwise and it has to be, about the origin, just do one thing, interchange their places. Interchange the places of the coordinates. That means make x as y and y as x, and also put a negative sign in the new y coordinate. That is how we'll do. So let us first of all find out the coordinates of the points. What are the coordinates, guys? The coordinates here, this coordinate is simply 2, 2. If I write it, it would be 2, 2. What are the coordinates for this point? This vertex has the coordinate 6, 2, isn't it? And what about this top coordinate? This top point, this is 6, 4. Isn't it, guys? The coordinates of the vertices of the triangle T are mentioned. Now, to rotate it, I need to have the new coordinates. So like if I talk about the first point is 2, 2. So when I rotate it 90° clockwise about the origin, what would be the change? First of all, this y becomes x, that is 2, and this x becomes y with a negative sign. So this becomes 2 minus 2. So the first coordinate would be 2 minus 2. Moving ahead, the second coordinate of the point, or I should say, the coordinate of the second point is 6, 2. So if I rotate it clockwise 90°, first of all it will interchange. So 6 becomes 2, while 2 becomes 6 with a negative sign. So it would be 2 minus 6. So the coordinates of the second point is 2 comma minus 6. When we talk about the third point, it is 6 comma 4. And when we translate it 90 degree, or I should say rotate it 90 degree clockwise about the origin, this 6 becomes 4, interchanging the places, while 4 becomes minus 6. So guys, these are the coordinates of the rotated triangle that we are just about to plot. I hope you are clear. 90 degree rotation clockwise about origin, simply interchange the coordinates, make x as y and y as x, and also do not forget to put a negative sign to the new y coordinate that you will get. Right? So let us plot it now. So yes, what is my first point? First point is 2 comma minus 2. 2 comma minus 2 would be x2 and y minus 2. So it is somewhere here. 2 comma minus 2. Next is 2 comma minus 6. So 2 comma minus 6 will be here. This is 2 comma minus 2. This is 2 comma minus 6. And the last point's coordinate is 4 comma minus 6. So 4 to the right direction and 6 at the bottom. So it would be here. 4 comma minus 6. Let us now join it and make the rotated triangle. So it would be from here till here. Right guys? Let us join all the coordinates, all the vertices. Use your ruler to do so that you get the perfect image. The rotated image of the triangle T. This is what it would look like. Right guys, this is the rotated triangle T, 90 degree clockwise about the center, that is the origin. I hope you are clear with this as well. Isn't this question covering everything guys till now? I have seen translation. If I talk about, we have done translation from its original position to this position. Then we have done the single transformation, that means how to get it back at the original place. Then also we have done the reflection about a line, and then we are rotating it. So it's a very good question. It is testing everything related to that translation chapter. Right? Moving ahead, we are still not done guys. We are still not done. Now is the enlargement. Enlarge triangle T by scale factor minus 1 by 2. About the center, this is minus 1 by 2. I'll just mention it properly. It might not be visible. So minus 1 by 2 is the scale factor. The center should be 0 comma 0, and we have to label the image P. Right? So to do that, I'll use the previous page only. Okay, we have to enlarge the triangle T by the scale factor minus 1 by 2. Here, I also want to, plot that triangle which was done over there. So here, if I tell you it was somewhere we are keeping all our drawings at one page only to get the real feel what you will write in the exam. Okay, and this was, isn't it? So we have done till now all this. Now we are supposed to enlarge this triangle. We have to enlarge triangle T by the scale factor minus 1 by 2. Minus the negative sign tells us that it is going to be reduced, isn't it? And negative 1 by 2, that has to be reduced by half of the size. Whatever may be the length of the sides, it will be reduced to half. That is what it tells, and it's a negative sign. So I'll let you know what needs to be done. The center should be 0 comma 0 only, and we have to label that enlarged image as P. So again guys, a very important concept. Whenever it's about enlargement, about a scale factor. So whatever is the scale factor, let us write. Scale factor is equal to minus 1 by 2. That means all the coordinates of the vertices of the triangle must be multiplied with minus 1 by 2. So if I do so, let us look at it. What are the vertices? 2 comma 2 is the vertex. So here 2 will be multiplied with minus 1 by 2, and the y coordinate is again 2, so it will be also multiplied with minus 1 by 2. That will result into what? 2 cancels 2, we are left with minus 1 comma minus 1. What are we getting? The coordinate of this point becomes minus 1 comma minus 1, and when we talk about 6 comma 2, I'll multiply it with minus 1 by 2, and also this 2 needs to be multiplied with minus 1 by 2. That will result into minus 3 comma minus 1, and at last 6 comma 4. So 6 will be multiplied with minus 1 by 2, and 4 will also be multiplied with minus 1 by 2. So it will be minus 3 comma minus 2, right? So these are the points that we will plot it on the graph. So yes, these are the points that we need to plot, and then we will get the triangle which is enlarged by the scale of minus 1 by 2 about the center 0 comma 0. Let us plot these points, guys, quickly. Here, what is the first point? Minus 1 comma minus 1. Minus 1 comma minus 1. This is the first point. What is the second vertex? It is going to be minus 3 comma minus 1. So minus 3 comma minus 1. This is where it is. And then we have the third vertex as minus 3 comma minus 2. So minus 3 comma minus 2. These are the vertices of the enlarged triangle T by the scale factor minus 1 by 2 about the center 0 comma 0. Let us join it quickly to get the proper triangle. So it will be from here till here. Then this is what it looks like. Yes, this is what it is. And then at last making the hypotenuse. Yes, and we have to label it as P. Let us write it as P. So this is the enlargement of triangle T by the scale factor minus 1 by 2 about the center 0 comma 0. I hope this part is also clear. What we have done till now, we have translated, we have drawn a line along which we have reflected this triangle. We also have rotated the triangle, and then we have enlarged the triangle as well. Moving ahead, there is one more part left. Describe fully the single transformation that maps triangle P onto triangle T. Let us have a look at it. Again, it's about single transformation. So if I transform it from P to T, I have to map it completely from P to T. So the thing is, I have to go reverse. To go reverse, if I have minus 1 comma minus 1 as the coordinates, what should I do to these coordinates to get 2 comma 2? It's simple maths, guys. If I have to get 2 from minus 1, I would multiply it with minus 2, isn't it? Because minus 1 times minus 2 will be 2. Isn't it? If we have minus 3, I need to get back to 6. So minus 3 needs to be multiplied with minus 2. That only will give me 6. Isn't it? So to go to the reverse process, what I see, since the transformation, or I should say the enlargement, had the scale factor of minus 1 by 2, the new transformation, or I should say the new mapping from P to T will be when we enlarge it by the scale factor minus 2, because when I multiply the coordinates of triangle P with minus 2 each, I will get back the coordinates of the triangle T. So that is what we will write over here. Let us write it. So here the single transformation would be, let me write it for you, single transformation that maps triangle P onto triangle T is enlarging P by scale factor. What is the scale factor? -2 about center 0, 0. Right? This is what is the single transformation. We have to enlarge the triangle P by the scale factor -2 with center 0, 0. So this is what we need to do in this question 1. Isn't this very interesting? If I look at it, we have translated triangle T to this new position K. Then we have reflected triangle T along this y equal to 4 line. We also have rotated triangle T to a new position. We have enlarged triangle T to triangle P, and we also have done the single transformation wherein we got back K, we got back T from K as well as T from P. So this question is all about the knowledge of enlargement, translation, transformation, and also the reflection. I hope you are clear with this. Note it down properly. Do look at this carefully so that you don't do any mistake in such type of questions. Right? Now let us move ahead to the next question, that is question number 2.